Hello everyone, how are you all? I hope you all are doing well. So today I welcome you all in this session. This is going to be lecture number 3 of this chapter, Source of Energy. So let's move on to the next slide without any delay. Okay students, so here we are. Here we will be talking about the nuclear energy. How can we utilize the nuclear energy to produce or to generate electricity? So basically guys, here first of all you need to understand that in an atom there is a nucleus at the center of the atom. Okay, so there are two types of reactions. First one is nuclear fission reaction and another one is nuclear fusion reaction. So in these two reactions, what happens if I talk about the nuclear fission reaction? So in this reaction, one nucleus divide into some smaller nucleus. Okay. So here you can say nuclear is decomposed into some smaller nucleus, but it is not like decomposition reaction. It's not a chemical reaction. Okay, here basically nuclear is divided. But if I talk about the nuclear fusion reaction, so in this reaction nucleus, or you can say smaller nucleus, combine to form a big nucleus or a larger nucleus. So this is nuclear fusion reaction. If I give you the example of nuclear fission reaction, so sun is a great example, because in sun what happens, nucleus combine to form a big nucleus or a larger nucleus, and in this reaction lots of heat is produced. Okay, so this is the responsible for the heat, or you can say for the energy of sun. Okay, sun is very hot. Why? Because of this reaction. So this is the reason for the energy in sun, because in sun this nuclear fusion reaction takes place. I hope guys this point is clear to you. Okay, let me give you some important examples. Basically in sun, two hydrogen combines and it forms helium. Okay, it forms helium. Okay, so this is all about nuclear fusion reaction. Now in nuclear fission reaction, as I already told you, that one nucleus divides into a smaller nucleus. Okay, and in this reaction also lots of heat is produced. Okay, in this reaction also lots of heat is produced, so we can use these heat to rotate the turbine. I hope guys this point is clear to you. Now guys, let me take you to the another slide to give you an example of nuclear fission. Okay, nuclear fission. So here you can see that when one neutron is bombarded into the nucleus, so this nucleus will be divided into two other, or you can say two smaller nucleus. And you can also see that with these two nucleus there is three neutron. There are three neutron as well which are released. Now these three neutrons will further bombard and then it will again you can say it will again break another nucleus. So this reaction will continue. Now guys, each time neutron bombard on this nucleus and it splits these two nucleus into two smaller nucleus, so lots of energy is released. Okay, you can see that it is striking, or you can say it is colliding with these nucleus, and this nucleus is divided into two smaller nucleus, so lots of energy is released. You can see that this type of energy is released, and this is very high amount of energy. So you can say 1 gram of this, you can say this reaction will produce lots of heat. Okay, but this reaction is uncontrollable. You can see that when this neutron bombard on this nucleus, so with this reaction you can see that 3 more neutron released. Now these 3 neutrons will again continue this reaction, and this reaction will become uncontrollable. Okay, because these 3 neutrons will further bombard on the other nucleus, and again whenever this neutron will collide with the other nucleus, lots of heat is again released. So that's why this reaction will become uncontrollable and lots of heat is produced. So basically guys, this also is used, this nuclear fission is also used in the nuclear weapons, like in Japan, in Nagasaki and Hiroshima. So this is about the nuclear fission. I hope guys this point is clear to you. So let's go back to the nuclear energy. Okay. So guys, as I already told you that nuclear fission reaction is uncontrollable because the neutron will be released. Okay, each time the nucleus is divided, some more neutrons also released. So what do? We use the control rods. Now what is the work of this control rods? Basically these rods will observe the neutrons. Okay, it will observe the extra neutrons. So when it observes the extra neutron, so this reaction becomes controllable. I hope guys this point is clear to you. So the heat produced in this reaction, as I told you that lots of heat is produced in this reaction. So this heat is used to boil this water and convert it into the steam. So this steam is used to rotate the turbine. As you can see in this picture that this water which is passing here is heated by the energy produced by the nuclear reaction. So this is converted into the steam, and this steam is rotating the turbine. And we all know that whenever turbine rotates, the generator produces electricity, and this electricity is distributed, or you can say is transmitted to our houses. Now this steam, okay, after rotating the turbine, or you can say after making the turbine rotate, this steam again comes to this condenser, and this condenser again condense the steam and convert it into the water. Now this water is again, you can say it is again sent to these, you can say this part where heat is released. So again this water heats, and this is converted into the steam, and again this steam makes the turbine rotate, and after the rotation, or you can say this steam after rotating the turbine, this again comes into the condenser, and this condenser condense this steam and again convert it into the liquid, and this liquid is sent to this part where heat is released and this process goes on. So I hope guys this point is clear to you that how in a nuclear reactor the electricity is generated by the help of nuclear energy. Basically, the reason here is the nuclear fission. So to understand nuclear fission is very important. So guys, let's talk about the definition of this. So it is the energy possessed by the nucleus of an atom. Okay, so whenever nucleus splits into two parts, so lots of energy is produced. So this energy is used in nuclear energy. It is the process due to which energy of a nucleus is released. So in this process, the energy of nucleus is released. This energy can be used to heat water and convert it into the steam. Now guys, let us talk about the advantages of nuclear energy. So the first advantage is alternative source of energy due to depletion of fossil fuels. So this is a big advantage. So guys, what happens in nuclear energy can be used as an alternative source because fossil fuels will not be available in future. Okay, because it is not a renewable energy resource. Okay, these resources will it may be finished in future. So this is a, you can say this is an alternative source of energy. So when the fossil fuels will deplete, or you can say when it is finished, so we will use the nuclear energy, okay, to generate the electricity. Now guys, from a small amount of fuel a large amount of energy is released. So this is also very important advantage, as I told you that by very, you can say, a small amount of fuel a large amount of energy is released. So this is very good advantage of this nuclear energy. Now guys, if I talk about the disadvantages of nuclear energy, then the first disadvantage of the nuclear energy is that this nuclear waste is very dangerous to our health. Okay, this is cancerous to our health. Okay, it may cause cancer. So that's why if this is, you can say, if this waste is leakage, so it will, you can say, it will bring disaster. Okay, and it will affect the life around it. So that's why it is a disadvantage of nuclear energy. Now guys, if I talk about the other disadvantage, then high cost of setting up of nuclear plant. Basically, to protect the radiations, okay, to protect us from the radiation, we need to make, you can say, make this nuclear power reactor, or you can say that we have to use lots of protection while making this power plant. So this will cost a lot of money. Okay, so that's why the cost of setting up this nuclear plant is very high. It is very expensive. So this is also an, or you can say this is also a disadvantage of nuclear energy. I hope guys these points are clear to you. So what we have seen yet, we have seen that there is two type of nuclear reaction. First one is nuclear fission. So in nuclear fission, one nucleus is divided into two smaller nucleus, and in this reaction lots of heat is released. Lots of heat is released, and this heat can be used to rotate the turbine. Now, the other type of reaction is nuclear fusion. And in nuclear fusion reaction, two nucleus combine to form one larger nucleus. And you have already seen that I have also given you this example that in sun this nuclear fusion reaction takes place. Okay, where two hydrogen atom combine to form one helium atom, and this process releases lots of energy. I hope guys these two reaction is clear to you. Then we also understood this by the help of this GIF. Here you can see one neutron is basically bombarded into this nucleus, and it is you can say decomposing this nucleus into two parts. Okay, and with these two parts we are also getting these three neutrons, and these three neutrons will continue this reaction. It will again strike with other nucleus and it will split them. So each time they bombard or each time they collide with other nucleus, lots of energy is released. So that's why it becomes uncontrollable reaction. So to control this, we use these control rods. So basically, these control rods absorb the extra neutrons. Okay, and this reaction becomes controllable. Okay, now guys, this heat which is produced or you can say is released in this process, it is used to convert the water into the steam, and this steam is sent to the turbine and the turbine start rotating. So when turbine rotates, then we all know that whenever turbine rotates, the generator produces electricity, and this electricity is transmitted to this, you can say, to our houses. I hope guys this point is clear to you. Now this steam is sent to the condenser, and the condenser condense the steam and convert it into the liquid water, and this water again sent to this, you can say, to this part where heat is released, and this process goes on and we get the continuous electricity. Okay, I hope guys this point is clear to you. Now we had seen that advantages of nuclear energy. The first advantage is that it can be used as an alternative source of energy due to depletion of fossil fuels. The other point is, from a small amount of fuel, a large amount of energy is released. This is an advantage. And if I talk about the disadvantage, then because this nuclear wastage is very, very risky to our life. Okay, it is cancerous. So it may cause cancer because alpha, beta, gamma radiations are always very dangerous. So if there is any leakage in this reactor, so it may prove very harmful to us. Okay guys, now the other disadvantage of this nuclear power reactor is that high cost of setting up of nuclear plant. Basically, we need a protection from the radioactive, or you can say radioactive substances. So to protect from us from the radiation, the cost of this power plant or this nuclear plant is very, very high. So it is very expensive for us. So I hope guys this is clear to you that how do we produce or generate electricity from a nuclear power plant. So if it is clear to you, now let's move on to the next slide. So guys, before we move on to the next type of energy, let me give you another information, and that is basically in nuclear fission reaction, what happens? Some mass is destroyed. It means that in chemical reaction we had seen that the mass of the reactant is equal to the mass of the product. But here this is not applicable. In this reaction, what happens? The mass of the reactant is not equal to the mass of the product. Or you can say the mass of the product is slightly lesser to the mass of the reactant. So basically, what happened? This mass, let's suppose that delta M is the mass which is decreased. So this mass will be converted into the energy. So this is converted into the high amount of energy, because we know that E is equals to mc square. So this is the relation, or this equation shows the relation between the energy and the mass. So you can see that this c is the speed of light, and speed of light is 3 multiplied with 10 to the power 8 meter per second. Okay, this is speed of light. So you can see that even if the delta m is very less, so let's suppose this is delta m, but here this delta m is multiplied with c, which is 3 multiplied with 10 to the power 8, and this delta m is multiplied with this speed of light, which is already very high, and the square of the speed of light. So the energy will become very high. So even if the small amount of mass is destroyed, so this mass is converted into such high amount of energy. So that's why this is an advantage of the nuclear power plant. I hope guys these points are getting clear to you. So now let's move on to the next slide, and let us talk about the tidal energy. So guys, we all know that whenever there is high tide, so water comes towards the land, and whenever there is low tide, the water goes from the land towards the sea. So in both the situation, you can see that this turbine is rotating. Okay, so here what we are doing? We are using the tidal energy to rotate this turbine. You can see that this turbine is rotating due to the tidal energy. Now, what is the location where this tidal energy can be used? So in Gulf of Kutch, okay, which is in Gujarat, and in West Bengal. So in these areas, or these coastal areas, we can use the tidal energy to convert the mechanical energy into the electrical energy, which simply means we can use this energy to rotate the turbine, and this turbine, or due to the rotation of this turbine, the electricity is generated. Okay, so I hope guys this point is clear to you. So it is written that it depends upon harnessing the rise and fall of sea level due to tidal action. So we all know that due to tidal action, there is the flow of water. So This rise and fall of water can be used to rotate the turbine. Okay. Now, the dams are constructed across a narrow part of sea and turbine converts tidal energy into electrical energy. So this is basically what? This is a dam, and these dams are constructed into a narrow part of sea so that we can use the tidal energy into the electrical energy. Now if I talk about the disadvantage, so uniform tidal action is not seen. Sometimes the tidal action is so much and sometimes this is very less. So that's why, because this is not uniform, so this is a disadvantage of tidal energy. So you can also write some of the advantages by yourself, that it is not causing any pollution. Okay, not causing any pollution. This is a very good advantages of the tidal energy. So you can write it by your own. So now guys, let's move on to the next slide and let's talk about the wave energy. So we all know that there is some kinetic energy into the waves. So this kinetic energy of the waves can be used to rotate turbines, because waves come with a speed, and that's why there is some kinetic energy in those waves. So these energy can be used to rotate the turbine. So thus the turbine rotates and it generates electricity. Basically, in tidal energy, what we are doing, we are using this tidal action. Okay, sometimes it is high tide, sometimes it is low tide. And in wave energy, what we are doing, we are converting the wave, or you can say the kinetic energy, or we are using the kinetic energy to rotate the turbine and generating electricity. So this was all about the wave and tidal energy. So I hope guys these points are clear to you. So first of all, we had seen what is nuclear energy, and in the nuclear energy we had seen two processes, nuclear fission and nuclear fusion. So nuclear fission is used in our nucleus power plant, where we heat water, make its steam to rotate turbine and generate electricity. Okay, and after that we had already seen that even a small amount of mass, if it is converted into the energy, so the energy is very higher. Okay, after that we had seen the tidal energy, and the tidal energy of the sea can be used to rotate turbine, and when turbine rotates it generates electricity. So this point we already know. Okay, and what are the disadvantages of this tidal energy? So you know that uniform tidal action is not seen. Okay, so because there is no uniform action or uniform tidal action, so it has become a disadvantage of tidal energy. Okay, after that, if I talk about the advantages, so one advantage is clearly visible, that there is no burning involved in this process. There is no burning involved in this process. So that's why it is not causing any type of pollution. Okay, I hope guys this point is clear to you. So after that we had seen the wave energy. So you can use the wave to rotate this turbine. Okay, and when this turbine rotates, so it basically generates electricity. So in both the cases we are using the tidal and wave energy to rotate the turbine. One more question is very important, that what is the work of the control rods which we have seen in nuclear energy. So this control rods basically control the reaction, because nuclear fission reaction is uncontrollable. So to control the reaction, we use this control rods which observe the extra neutron and it controls the reaction. So I hope guys all these points are clear to you. If these points is clear to you, so I am ending this lecture and I will see you in the next lecture. So till then, enjoy and thank you so much and see you in the next lecture.